Hey, this is Paul, and today we'll be working on the 6, which is probably a fire hazard. This problem is about a 1000 by 1000 grid, which is fixed size, based on lights, and these lights can be turned on and off. Every single light can be turned on and off differently from other ones. And for our input, we have a list of instructions to turn off, turn on, or toggle various ranges, inclusive ranges, on coordinate space. So let's look at the data file. So it's turning on, turning off, and toggling. And there's two coordinates, x, y, or y, x, it doesn't really matter. It's a square matrix, so we can do it, as long as we're consistent with our x, y position, we can use it in any way. We can also use A, B, and so on. But the thing is that we need to turn on, turn off ranges of lights. So this specific part, let's use it to read the data. First of all, it's a good idea to just set up the data. I've got the data file already here. So let's use the grid, which is right. So the grid is a matrix of falses. It's just for to initialize the matrix by having all the lights off. False or true means that the light is on, or true is on. And when toggling, we just need to have an inverse of this. Boolean value. So let's just do A and x range 1000, and for this case also B and x range 1000. That's a pretty straightforward usage of two inline for cycles to define the initializer. Day 6, yes, as F, and we start reading data. It's line based, so that's good. So by reading a line, we need to get several things from it. We don't care about this general stuff. That's just for readability, I suppose. We care about the instruction, what to do with specific range, and the ranges starting point and ending points. As in point, the point has x and y values, so it might just be some kind of square or other. It could be, the easiest approach would be just using one point, and the most common, I believe, will be using a range of points. So we need to read the data. For this, let's just use regular expressions. Regular expressions are good for looking through the string and looking for a specific type of data. So for this case, for regular expressions, I just need to extract these specific coordinates. And right, so let's say coordinates search is search. Is just a regular expression, the short version for that. What we're searching for is simply a group of numbers which are actually without a space, which are separated by a comma. Then we don't really care about other characters, which is mostly through. We can actually write through, yeah. And the other group is also number separated by a comma without any kind of space. So what we get here is these two numbers, but the first group consists of these, and the second group consists of these two numbers. For this, we can simply extract it into, let's say, point 1, coordinates search group 1. And since we get this kind of thing, we actually want to get another useful thing, that instead we have a string in here, but we want to get a two numbers separated. So let's just split it by this comma symbol. The same goes for point 2. Coordinates group 2 split. And we have those 2 points. Now, what we need to define ourselves is the actual operations that will have to happen just to change the grid, instead of having the lights off, just to toggle them to turn on, or like to turn off. I mean, some of the lamps can be turned off anyway. So let's define, that's a function which is turn on. I think that in general it's okay to simply, I mean, we can do a one function, and we can do point 1, p1, p2, and the action. So at this point, p1 has x1 and x2. So for p1, the first coordinate to, wait, let me think of it. So it's I need to go through from one part to the another. So I should probably just set it as I. Let's just look at the Python range from, I mean, I just want to go from one part to the another one. Oh yeah, so that's probably better. X range p1 0, p2 0. So what we get here is some kind of x range, which can actually be, if we have p1 the first part, second, yeah, we have, let's say, p1 first element as, let's say, 5, and at this case if p2 0 is 2, we get an x range as 5 4 3 2, which is quite useful, I think, because what it does is it doesn't really care if it's an incrementing or decremental range. It generates it for us. So that's only for the first part. For another, since we have a matrix, we need 2 coordinates used. Let's use the same for p2. For the second coordinates, I mean, it's not p2. So the second coordinate is indexed as 1, and yes, so we have it, and that's pretty much it. Now what we need to do is simply apply the action. The action can be, I don't know, I mean, I'm not sure if it's a good idea, but I mean, the actions will overlap. What I'm thinking about is action is, let's say, on pass. I mean, let's just use it. I mean, it's not that difficult. Grid I j is true. Else if action is off, we just set it to false. And the final action that we can accept is toggle, which is using inverse. I mean, simply said that it's not the same point. Okay, so it doesn't return anything. I mean, we can always have else action, just to be like defensive in a way. Okay. So we have these two coordinates that we will pass. Right, so we also need to get the action. So the action is a bit more tricky because in general, if let me see what turn on, turn off, we can simply get on, turn on, just to be sure. I mean, turn on in line is 10.1. 0.2 and the action is on, else turn off and line. We simply do the same, turning off -1, 0.2 and off, and the last one is just toggle in line 10.1, 0.2 and toggle. And we want to, yeah, a good question is, what do we want to get out of it? How many lights are lit? So, yeah, we can simply count it, I suppose. Grid, count, proof. I'm not sure if that works out, but let's hope so. We'll see what it will print out. Oh yes, common mistake. I forgot to enter the actual string that we set your integer. That's right. We need integers here. That's a bit nifty, but I mean, there's probably a better way to just predefine that and not use it later, but a bit lazy for that. So it's going, I suppose, it's 0. That's wrong counting, but we can do a simple grid print. And if we have some kind of, I mean, if we can see that something is true, there's some true, yeah, we can see that at least this part is true. So let's see. Yeah, let's go to straightforward print true value. I mean, count true matrix. No. Okay. Some. Oh, that makes sense. So, what we want to do is, yeah, we'll just need another variable for this, unfortunately. So, I mean, I think that it should work this way. Takes some time. And there's 5, 6, 8, 6, 5, 8. Let's see the results. Okay, 5, 6, 8. And that's apparently the wrong answer. I wonder why. Is there some kind of edge cases for this? Would toggle the first line of 1,000 lines? No. Lights in your grid are numbered from 0 to 999 in each direction. The lights at each corner, blah blah blah. And instructions include whether to turn on toggle various inclusive ranges with given as coordinate pairs. Each coordinate pair represents opposite corners of a rectangle, inclusive a coordinate pair. Okay, so it might just be that's our range function. Let's just print, let's just use, for this case, range to get the results, because x range doesn't put on, well, it's an iterator, so p1, 0, yes, and p2, 0. Before that we have to print out p1, 0, p2, 0, because it has to include them. I mean, I just need to see if it's the case. If it's not, then I suppose it's okay. I can simply stop. Yeah, so it does not include the last part, which is quite bad. And we need to search for Python range inclusive. Yeah, so I suppose it's simply adding +1 at the end. Well, if this works, then it's just the case of using the range or x range part. So yeah, so it's 5, 6, and 4 9s. So this is the part 1, and the part 1 was only about lights being lit. And the part 2 says that the translations are a bit different, and the light grid has individual brightness controls. Each light can have a brightness of 0 or more, so it means that the brightness can go up to any kind of level. The phrase turn on means that we have to increase by 1, turn off decrease by 1, and toggle increase the brightness of those lights by 2. Okay, so toggle just means increase by 2. Then we need to get the sum of the brightness. Our previous solution was a bit different, but we can simply use the same one for day 6 part 2. Instead of using true, we just increase it by 1. We also need to check if this grid and grid ij is more than 0, and we can simply decrease it by 1. And for this case, we just need to increase it by 2, and we have to set here as zeros instead of false. Yes, this also. So that's it. Yeah, so okay. I mean, this should be it, I think. So what we do here is just calculate the sum of all brightnesses. So since there's no negative value, or at least the condition for this part 2 is defined as no negative values, and we do a simple check if this specific pixel, the specific light has a value higher than 0. If it doesn't, we just go else if. That's right, we just go to 0. Oh, but then wait. Yeah, that's a bad thing. I mean, it would say unknown action when it's not an unknown action. So let's just use an internal if, which is just for the case of staying in the same logic. So if we have the number already higher than 0, so we just decrease it by 1 until it's 0, and when it's 0 it will just skip it. And the other methods are always incrementing it, so it's not a big problem at all. So let's see if it runs. Oh wait, so it's not the right part. And yeah, we have to rename that. One second. Let's just close that. Day6 part 2. Should work right now. So okay, so the number is definitely bigger. Yeah. So the number should be 178361115. So yeah, that's the number, and I mean our solution had to do several small modifications, let's say, and that's it. I mean, that's all that we needed. Thank you for watching, and see you on the next day.